All right, welcome to 17.0 Machine Setup. Today we're going to cover how to set up a machine in Detailer. So go ahead and launch FrameCAD Detailer if you don't already have it open. It's this little icon down here with the D. You can start with a brand new file. You can open your previous file um, or whatever you want. The machine setups tell Detailer the following information: tools available for the machine, tool lengths, section profiles that the machine can produce, dimple heights, which are the distance from the web of the steel section to the center of the dimple, and flange hole heights, and various other things. As a general rule of thumb, you're always going to want to modify your machine setups using metric units. That is super important. Always modify machine setups using metric units. All right, so to get started, I'm going to go ahead and close this elevation view here. I'm going to come down to Edit. I'm going to go to Options. Right here in the General tab, I'm going to go ahead and switch my units to metric right away. Go ahead and hit OK. That'll apply those new settings and also close that dialog box. The next thing we want to do is under the Edit drop-down menu, under Options, we're going to look for, let me go back, Edit, Machine Setups. Control M is the keyboard shortcut for that. So if I hit Cancel, Control M, there we go. That'll produce this Machine Setups dialog box here for me. And I have one machine already set up here in Detailer for me. This is the actual machine set up for our FrameCAD at Orange Coast College. So when I want to actually produce any projects using that FrameCAD, I can go ahead and use this machine setup. You may also have a demo machine setup. If you do, go ahead and select that demo machine setup and then click here, delete. Okay, because we're not going to need it, and we're going to go ahead and create our own. Okay, if you're enrolled in any of my other classes, such as FrameCAD Workshop, and you have this machine set up here, do not delete that one. Keep that there. You can have multiple machine setups here in Detailer, right? If you were a business that had FrameCAD machines, you might have one, you might have two, might have five, and so you would need a different setup for each one. Why? Well, each one might be of a different size. Each one might have a different gauge of steel or a different section profile that it can create. So what we're going to do for this studio class is we're going to keep this F325IT from our workshop class, and we're just going to go ahead and create a theoretical machine setup for this studio class. So to get started with that, I'm going to go ahead and come down to this drop-down menu here next to Machine Model, and I'm looking for F325IT. Oops, sorry, this one right here, the one that was already selected. And we can go ahead and click on Create. All right. Be aware of where that new created machine is. It's this one right here, right? This is the one from my workshop class. We're not touching that. All the settings are already dialed in. We're going to touch this brand new one right here. All right. First thing I want to do is, for the purpose of this studio class, is I'm going to change the machine setup name, and I'm going to call it FrameCAD Studio and put that in parentheses. Okay. Now you'll see in the handout that it does say 2, and if it doesn't say 2, I may have changed it, but this used to be an exercise for my advanced studio students, and now it's incorporated into Studio 1. So call it FrameCAD Studio or Studio 2, whichever one you want, doesn't matter. I've got that newly created one. Go ahead and hit Apply to go ahead and solidify some of those settings that we added. The next thing I want to do is I'm going to show you the profile drawing. So when you get a FrameCAD machine from the company, Um, you'll order whichever machine that you want. There's about, I think, five different models. Um, and then you'll choose what services you need from that machine. And once you do, FrameCAD will create this profile drawing for you, so that way you put this in your books and you know exactly what your machine can produce, right? It has limitations. It can't just make a 12-inch flange or, sorry, 12-inch web, right? You can't just do floor joists on my F325 IT. Ours can only produce a 3 5/8 by 1 5/8. So this is the profile drawing. This is the plan view, right? This one right here. And let's see. All right, let's go full screen this. All right, so this is our plan drawing. All right, so we're looking at a stud or stick in plan view, right? It's laying on its web, which is that widest part of the stud, and we're looking straight down on it as if it was a floor plan. So the first tool that we do have is this swage, right? You can see what happens when a piece of steel is swaged, right? It gets squeezed in this area here. There are specific settings dedicated to swaging, right? When a swage occurs, the product will be 2.17 inches of squeezing. Okay, these numbers here in brackets are inches. These numbers here are millimeters. Okay, we have web holes. So I can produce 1, 2, 3 holes in the web of our stud or stick. Those are all the numbers for that. I can produce a flange hole. You can't perceive a flange hole here because we're looking at the plan view. This is the web that we're looking at. The flange are the two sides. So if I go down to this drawing, zoom out a little bit, this drawing represents a side elevation of this same exact stud. So my flange hole doesn't show up there, but it does show up right here. And it's this little hole right there. Okay, and again, there's my swage in plan view. That's my swage, oops, here in elevation, right here. We have a web notch, big hole that cuts into the web of the stick. We have our lip cut, which cuts off the lips of the stick. We have a flange cut, which cuts off the flanges of the stick. We could do a left flange cut or a right flange cut. This is our service hole. We have a long service hole. A typical service hole is just one circle. We have an elongated one. We have a chamfer right here. That's what a chamfer looks like. You usually see chamfers when you have like a brace component, some sort of angled piece, and it needs some extra clearance to make sure that it doesn't run into the web of another stud. We have our dimples, of course. That's what it looks like here in plan view. Can't really perceive it because it's on the sides or the flanges. So if I come to our elevation view, there's our dimples right there. Okay, notice all of the dimensions all over this entire sheet, right? We're going to need to input those at some point. And then this is section BB. So if I look at this elevation drawing, BB, it's cutting right through where there's a swage. So section BB, swaged C section. This is a 1:1 scale, and these are the measurements of our stud when it gets swaged. Now let's look at section AA. And if I look at it here in this elevation drawing, AA is not even cutting through any part of the steel. It's basically an elevation view of this stud way outside of it. So if I go back to AA, here's our actual profile setup. These are the actual measurements for our typical profile for our machine. Okay, so if I zoom into that one, these are our lips, right over here, 12.7, 12.7 millimeters. Okay, lip, lip. It's kind of hard to tell, but maybe if I zoom in just a little bit more, you can see that these two lip heights are not aligned, right? If I go ahead and scooch this all the way up, so that way this right lip is aligned to the top of my screen, notice this lip over here is lower. Why is that? This is called a boxable profile. It means that if I needed to, I can print out two of these studs and flip one upon the other, and they can actually squeeze together to create a box section. Okay, that's when you have two studs that are front to front, squeezed together, and it produces a very rigid connection. It gives you a nice post. So that's a very special thing about our section, is that it is boxable. Okay, but the width is still 0.5 inches, 0.5, 0.5. And so for this thing to be boxable, if I go ahead and set that back up again, where this right lip is all the way at the top edge of my screen and this left one is lower, for that to occur, the sides or the flanges of my stud need to be of different measurements. So if we look here, 1.625, 1.70. Okay. And then of course we have our web. The web is the bottom one. It's the biggest, widest part of the section or stick. It's 3.625 inches. Okay. So when we say 3 5/8 by 1 5/8, that's what we mean. Okay, so if I took a calculator, let's come back here, go to my calculator app. Okay, if I divide 5 and 8, that's 625, right? Plus 3, 3.625. Okay. So going back here, 3.625 or 3 5/8, 1.625 or 1 5/8. But since we're setting up our machine, we're more worried about the metric number, this millimeters. 12.7, 12.7, 43.2, 92.1, and 41.3. All right, so back into Detailer. I'm going to flip back to Detailer. So this is a list of fitted tools. This is a list of available tools. These are all of the different tools that you can have in your machine. Now, obviously, our smaller machine does not have every single FrameCAD available tool, right? It only has certain ones. So the thing that you want to look out for is that for this theoretical FrameCAD machine that we have, we want to make sure that bolt hole, this one right here, is in the fitted tool section. We're going to need this tool, so you can do it in one of two ways. In this list, you can double click bolt hole, or maybe not. Just click it once, click this little left arrow, and it'll transfer over here to fitted tools. And let's find web hole. Okay, lots of different selections for web hole, and we want a web hole triple. Click on that left arrow, boop, moves from this list to the other list. Go ahead and hit apply to apply those settings. Tool lengths tab. Let's go to the tool lengths tab. Now that we fitted the correct tooling to our machine, we can move on to this tab. The tool lengths are the physical dimensions of the operations, such as punches and cutouts that the tools make on the profile as you operate your FrameCAD machine. If you're setting up your machine to suit your profile drawing, then you need to check if the default tool lengths match the ones on your profile drawing and change the values if needed. For this session, if you're following along, leave values as the default. Click on apply to save settings. So So we're going to leave those just the way they are. Let's go to the General tab. So we've confirmed our tool links. General tab has the following options: back-to-back tooling, minimum tag length, place extra chamfers, we have plate width differential. We can suppress the fasteners. We can add extra fastenings. We can change the extra fastenings distance. Okay, we're going to leave these alone as well. Clearance. Here in the clearance tab, we have bolt hole to end, brace to dimple, brace to web hole, chamfer tolerance, dimple to end, and clearance reference, and clearance, stick clearance, tool clearance, web hole to end. These are all described in the handout. So if you want to learn more about each one of these settings or any of the previous ones, check out the handout. It's got everything listed there. Here in the boxing tab, okay, remember, boxing has to do with the ability to flip one stud onto another one and squeeze them together to create a boxed stud. It has nothing to do with fighting. So boxing tab has box to box max hole delta, boxed edge length, boxing max dimple spacing, first dimple offset and last dimple offset. You can read about those in the handout. Got our section setups. All right, this is the most important one here. In this section, we're going to set up section profiles to whatever size we like using the interactive section profile interface right here on the right. Multiple sections can be set up specifically to suit one machine. These would usually be differentiated by material thickness and grade, but could also be different profile sizes as required for multi-profile machines. This will limit the user to a selection of profiles specific to that machine. Here's a note. Before setting up section sizes in Detailer, you must know what profile sizes, thicknesses, and grades your factory's machine is going to be running. This information can be sourced from the profile drawings that are supplied with the machine. So let's begin to define the section properties, such as the shape, the web, the flange, and lip dimensions, material properties, the section-specific options. For this machine setup, I have a default section of 89S, 89S41. This section can be modified to suit our drawing. For this session update, the left flange dimension, this one right here, should be set to 39. Okay, so go ahead and set that to 39. As you do that, you'll notice that this little section drawing updates, right? Left flange is now 39. Let's go ahead and change the name of the section as well. See, it says section right here. We can go and change the name right here. We're going to call it 89S41 underscore 0.75. Okay. Once you hit tab, right, you'll move on to another box, but the name will update automatically. So basically that naming scheme is something that you want to follow when you create new section profiles. This tells you the size, the shape, and the material thickness. So, shapes. If I click on this drop-down menu, SU, what does that mean? S, or sometimes referred to a C section, is a lipped stud, meaning it has lips, right? A U shape will not have lips. Okay. You may also see or run into T. It is an unlipped track. which is only for stud and track machines, or ST machines. All right, I'm going to switch this back to S for lipped stud. Let's go to section specific options. Dimple one height 20.50. Okay, that looks good. What is the dimple one height? So the dimple one height is the distance from the web of the member to the center of your main fastener. This includes dimples and screw holes. Remember, we're using metric right now, so none of these numbers are inches. This is 20.5 millimeters. The flange hole height is the distance from the web of a member to the center of the flange hole. Triple web hole spacing, that's the spacing between the center of the middle hole and each of the outer holes on the web of the section. Material properties. Okay. BMT is our base metal thickness. So 0.75 millimeters is what we want to have that set to. Steel spec is going to be AS1397. Coating, make sure that is set to Z275. Material grade G500. Export compatibility. You can check that the profile you have created is compatible with what can be run on your machine. In some circumstances, the values represented on the profile drawing may not be identical to what is set on the factory machine control. If the RFX section displays not compatible, uncheck the automatically configure checkbox and select the section size that is compatible with your machine. RFX section list will filter the list to sizes that are compatible with the machine selected and closest to what has been set up in the section tab. This profile name then needs to be replicated in the RFY label location for either metric or imperial applications. This label must replicate exactly what is set in your factory control software on your machine, so take note of any spaces in capital letters. All right, with all that, just make sure you hit apply. Next thing we're going to do is copy section. So make sure you're highlighting or selecting that specific section that we just modified. We like those settings and we don't want to have to go through and change those all over again. Click on copy section. This will give us the opportunity to create a new section. The first thing we're going to do is change the name of this brand new section. So click on, make sure that new section is highlighted here. Click on the section tab and change the name to 89S41, and we're going to change the thickness to 0.95. Okay. Next thing we want to do is we want to navigate on over to material properties, BMT 0.95. Make sure you hit apply to save all those settings. Okay. Please remember, only add sections based on the sizes that your machine can actually be configured to produce. Okay, just because I add in a brand new shape or brand new section in here, I can't just actually go and print it out with the machine. All right. Now we're going to look at exporting and importing our machine setups. This can be useful if you want to create one standard setup for all users to access and use the same configuration. So if I am the first one hired at a FrameCAD company, and I've been given the task to create this machine setup so that way what we design can be done in Detailer and printed out on our machines, I need to make sure to carefully make my machine setup. Once I do, I can save or export that machine setup so that way as we recruit new hires, they're not going to have to come in here and create their machine setup as well. If we let them do that, there's a high chance that they'll miss one number, one digit, read something off, not name it the same way that I name it, and that can be really important in a company. So to mitigate that, I, as the project manager at this company, might configure my machine setups, export it out, put it somewhere on the server, and after we get every new hire, just make sure that they import my settings, just so that we're all working off of the same exact settings. So, go ahead and OK. Under File, under Export, under Frame Types, Machine Setup, Steel Setups, we can choose our machine setup. Here's my Orange Coast College one. Here's the FrameCAD Studio one. I can click on that little arrow and it will allow me to export that specific machine setup. I'll get into frame types soon, but we could also export our frame types. We're not really going to touch steel material setups, but if we did, we could also export that. We can click on export, navigate to where you want to save this file. Definitely consider organizing where you save all of your files, not just for my class, but just in general. So I'm going to go to OCC 2025 Spring FrameCAD Studio 1 and 2. This is Studio 1, and I'm going to call this machine, spell it correctly, machine setup. Let's spell that correctly too. Okay. For file name, I'm going to choose my favorite file naming scheme. And save. Okay. It's super important that you know where you just put that. Now let's look at importing that file. I'm going to go back to Edit, go to Machine Setups. I'm going to carefully select FrameCAD Studio Machine, not the Orange Coast College one, just this one, and delete it. It's gone. I can no longer print to that machine. Okay. I said, okay. I'm a new hire. I want to start designing for my boss. I want to make a tiny house. I want to make a building in Detailer. I need to be able to use the correct machine. So, File, Import, Frame Types, Machine Setups, Steel Setups. Navigate to the location to where you saved that file, or if we want to go back to this theoretical, FrameCAD business, you might navigate through the server, right, to figure out, okay, I need to find where that machine setup file is. FrameCAD Studio 1, machine setup, 250417 Studio Machine Setup. It's a SUPS file. All right, I just imported it. Let's see what happens. Edit, machine setups, and voila, it's back, right? So that's how you create that machine setup. That's how you export it. And then that's how you import it. Okay. Going back to that SUPS file, if I navigate through my File Explorer, FrameCAD Studio 1, machine setup, okay, this is what it looks like. Studio machine setup. It is a file. It is a SUPS file. SUPS. .sups. Okay. If you have one of these files, never double click to open it. Okay. this is what's going to happen, right? Your computer is going to say, well, I don't know what file this is. What app do you want to use to open that? It's not going to know, and none of these are going to work. The only way to use a setup file is to go to Detailer, File, Import, Frame Types, and then you select your subs file. That's the only way. Okay, never double click it. Nothing will happen if you double click it, but just don't double click it. All right, for this assignment, I'm going to go to File. Edit. I'm going to do Machine Setups. Okay. And then you can go ahead and screenshot. Select this new machine setup that you created. Go ahead and screenshot this entire dialog box and turn that in for assignment 17. Alrighty. Thank you.